All right, everyone, good morning. And so this is the second part of timers and counters lecture. And today we're going to discuss the counters in detail. Last time we have discussed the timers, how to insert a timer and different types of timers, T on, T off, and pulse timers. And we have done few examples. And this is the continue. Today we're going to continue this counter section. And basically we're going to discuss three types of counters. The first one is the up counter, and that is CTU in codices, and the second one is CTD, which is the down counter, and finally we have CTUD, which is the up down count. So basically count is just to count any number or any inputs. For example, if you want to count any people to entering into a supermarket, you can add a sensor or IR sensor at the door and then couple that IR sensor to the PLC, and then you can insert this counter module in software. You can just count the number of the persons entered to a supermarket. Similar to that, we can implement different types of example for vehicle parking system, the number of vehicles enters to the parking lot. Likewise, or you can just add the counter to simple push button, and once you press the push button, you can count the number of attempts like that. So let's start with the up counter. So in the up counter, basically we have this function block. So it has the trigger, which is this. So this is the how it looks like in codices. You have several inputs and outputs. The CU is the trigger, which means like you have to use some pulse to start the counting. Typically, it is done with the rising edge signal. You can provide a pulsative square wave signal in the rising edge. This will trigger this rising edge and start the counting. So once for every single rising edge, can you see the screen now? Does everyone see the screen?
Yeah, sir, we can.
Yes, sir, we can see.
Okay, in the up counter, let me go to the presentation mode. Sorry, basic. As I mentioned, so there's a rising edge pulse. It could be a push button or any kind of encoder or any IR sensor coupled to there. So once this signal is provided, positive wave signal is provided to CU, the counter is updating its counting value. So this is that CV is the current value of the counter. So whenever you press this trigger, so the counter will be updated or incremented by 1, right? So it is incremented by 1, not any other value. And so this is the preset value. So that is a word, which means 16 bits. So you can define any value that you wish to have here. So for example, if you define 10, so when the counter is counting and incrementing, and this current value reaches to 10, the output will be set to high. So the output is a Boolean type. It gets true when the CV, the current value, is equals to the preset value. and until that it is 0. So anytime you can just reset this current value by inserting a reset pulse signal. So if you provide a reset high signal here, no matter what is the value here or the output, so the counter will be reset. So this value will go to 0, and if the output was at high, so that will be also goes to 0. So that's the basic principle of the counter. So this is providing a pulse signal so that you start the counting, and here you define the which value that you want to have your limit, and when the limit is reaches, the output get high. And whenever you want to reset the counter, you can press a pulsative signal to reset, so it will reset the counter. So the maximum value that you can have is 65535. This is 16-bit double F value. So normally we are not getting into that level of values, but still, if you want to get the upper limit, this is the upper limit. If the upper limit reaches, so it will either decreases or it will start from 0. So no, be careful, like when you're reaching this maximum level, so either you have to reset and start from beginning, or just bypass that signal to another counter, or just you can cascade the counters as well. So here's a simple example using the counter in Codesys. This is a ladder diagram. So we have a trigger signal connected here. It's a Boolean type, and reset, which is connected to a normally open contact. And I have provided the preset value as 10, which is my upper limit, and CVC counter 1, which is, you can add any name here, right? So even your name will work here. So that is my current variable of the current value of the counter. Here I get the output. So I have used a momentary push button to enable the trigger, and another momentary push button as the reset in the visualizations. Then I couple this, double click this push button and couple that variables to the same variable that I have used in the ladder diagram. So here also I have used a pilot lamp as the output. So all the variables should be linked to the ladder diagram. Then you can run the program and then simulate. So I will show you on demonstration how this works with in Codesys. Okay, now I'm in the Codesys environment. So you can see this is my counter. Same way you can import a counter, go to the functional blocks, and same way click this one and go to here, just insert a box and then select it as a counter. So pretty simple as what you have done in the in the timers. So either you can add here, or you can go to toolbar and insert that one. So go to here and you can see the counters. So CTU is the up counter, right? So is it clear for everyone how to import a counter? Did you see how it was done? Any questions?
So could you show that again?
Yeah, just you can go either here, insert box, right? Or you can right click, insert box, right? So anyway, you can insert the box, and it is asking go to standard counter CTU, right? And okay.
sir. Thank you.
So then you can rename the counter. So I have renamed this as 1. So here you have to define your default. It comes with normally open contact. So you have to define your variable. So I have defined the variable as trigger and reset, and PV value you can just type first you have to declare your timer counter, and so you can rename it to any name that you wish to have. And so then you have to just click this one and type whatever value, like if you want 12, and just type 12 and then enter. And here just define any parameter that you wish to have, like let's say A or something. If you want to add A, so it just type A and enter. So it is asking Boolean, just say Boolean, okay. And if it is B, then type B and enter. So it starts again, just Boolean, okay. And here just go to again and make a coil, insert a coil. So you can set it as output, maybe C, and it is also Boolean. And this is the current value that you want to have, like type any name, like let's say E. So it's a word, which means a 16-bit value. Then okay, right? So you have, now you know how to insert the timer and how to define this inputs and outputs. So these two are inputs. This is also input. This is your set value to enable the output. And here you can see the current value of the counter. When the count is working, you can see how this value is updating, right? So I'm just removing this because I already have this counter in my computer. So then go here, build. So you can build the program. And also visualization, also the same, like I have shown you in the last time, how to insert the push buttons. Since this is a momentary push button, so you know how to do that. So I'm not explaining that again. So if you forget, just go and watch the last video in the timer, so you will understand that. And then go to the online. So now I'm into the virtual PLC simulation method environment. So there wasn't any compilation errors. Then that's why I was able to get into the PLC. Now all I need to do is run the simulation. So I just go to debug, start the simulation. So now I have the access to my push button. So this is a momentary push button, which means like as long as I'm just holding the mouse key, it is high. When I release it, it will become 0, right? So when I press this one, so you can see trigger is high and the counter is updated to 1, and then I release that one. So the trigger became 0 and the output remains the same. The current value is 1. So again, I can press this one, count is updated. Likewise, you can increase up to 10. When it reaches to 10, the output becomes high, right? And so no matter, you can just keep continuing, the output will be high because it is over than the preset value, right? So if you want to reset the whole system or the counter, you can just press the reset button. That will enable this reset pin high. So the counter will be reset to 0, right? So if you are in the middle, before reaching the reset value, still you can reset, so it will become 0, and it will never set the output high, right? So it's pretty simple how to work with the up counter, and we can now move to the down counter. Right. So this is the down counter, and it also has the same inputs and outputs. The only thing different is you have to define your preset value as 10, and you have to load that value to the CV, or the current value, right? For example, now I can set this preset value as 10. So when I press load, 10 will be loaded here. This is my current value of my down counter. So it is down counting from 10, right? So whenever I press the trigger high, so the value is decremented by 1 from this preset value. If you don't press any this load, it won't work, right? So you have to define this your preset value and initiate with and press load, then it will go to here. So then you can trigger, and it is decreasing from the value here. And once this current value reaches to 0, the output get high, right? So it is decremented back to 0. So once it is reaches to 0, the output will be high. That's the main thing. So you can just press the trigger, so it is decreasing from the PV value. Make sure you should load this preset value to here by the time you start your system or the program. So this example of a down counter. Here also the same parameters: trigger, load, and preset value. And this is the current value, and this is the output. I have used my same push buttons, one for trigger and one for loading, and one for the output. So let me demonstrate it in this in Codesys, so then you will understand more clearly. All right. So this is the down counter. Same way that you can go to the insert box, and you can select the down counter. And here, so my preset value is 10, and so I have to load it to this here. So you have to build the program and then go online. This program is already built, so I don't have any errors, so I'm just logging. When you do it the first time, make sure you build the program. If there are compilation errors, and make sure you clear them before you run your simulation. Push button are the same. So I will upload all these examples to the LMS, so you can download the file and just run your simulation, or you can try by yourself. Right, so now I'm in the simulation environment. So as you can see here, so I haven't done any loading, which means the current value is 0, right? So it is not, this PV value is not loaded to the current value, which means the current value is 0, which set the output as high, because when this current value reaches to 0, the down counter set this output high, right? So I need to load my value, this preset value, to the current value of the counter. So in that case, I will press this load button. So now you can see now the current value of the counter is set to 10, right? So now it is loaded to the current value. Now all I need to do is just press the trigger, which is the starting the down counting. So every time I press it down, so it is decremented by 1. So I can go down as long as I wish to go, and when it reaches to 0, the output will be high, right? So no matter, I just press it, so it won't go below 0. If you want to start the system again, all you need to do is load it back. So that is also pretty simple. So hope everyone can understand it very clearly. Then we will move to the up-down counter. So the up-down counter is either you can use it as the up counter, or either you can use it as a down counter, or you can use it for both purposes. Right. So now, interestingly, it has two outputs. QU is the output of the up counter. QD is the output of the down count. Right. So it is an up-down counter. So you have two outputs: QU for up count output, and QD is for down count output. So you should have two several inputs. For up counting, you can just use this up count trigger. So whenever you make a positive edge pulse here, so the current value will be incremented. This is the current value. And same time, if you press this down count trigger, so the current value will be decremented, right? So it could be, for example, the application is like you have some kind of a supermarket here. So you have this enter, and you have enter, and this is exit door. So you can couple this enter door to the up counter, and you can couple this to the down counter. So then using this one, you can determine number of people inside the supermarket, right? Because whenever person enters, so it's counting up, and when someone leaves, it's counting down, which means like the output will display the number of people inside the supermarket, right? That's a pretty simple example of up-down count. Or either you can just use it as a up counter, like it doesn't matter. Like you can entirely use this as up counter, forget about the down counter, or you can entirely use this as a down counter. Right. Most of the time, if you're using both up and down, it's better to use this one. Otherwise, you can just use the up counter block or down counter block. Right. So reset here is like when you press this one, so the current value will be reset to 0. And load this, like you can define your preset value here, and when you press the load, it will update this current value of this up-down count, right? So for example, now if the PV is 5, so I can press the load, so the PV goes to here. Now it is starting from 5. So when I press up counter, so it is counting up, and so if it is go beyond that PV value, the output of CTDU, the up counter will be high. And if it goes to 0, this QD will be set to high, right? So this goes to high when the incremental value is go to more than the preset value, and this will be high when the current value goes to 0. Okay, now you can see this up-down count in codices. So I have up count, which is linked to this momentary push button in the visualization, and down count is set to down is set linked to down count, and load is linked here, and reset is linked to here. And preset value, rather I'm just typing here, I have done something here, because when I press this one, so I can just from my mouse pointer, I can increment or decrement my current value, right? So in the previous two example, I have just typed it here, but instead I have inserted this this window. So here I can, it's just like a up down here. And in order to visualize my current value, I have inserted a another toolbox which I can visualize here. So I will show you how to import this one first. So you know how to insert this momentary push button. So if you want to enter any value which is you want to update to any variable here, you can just go to properties toolbox. And screen control. Here you can see, like, when you press this one, so it is updating its value. When you press this one, it's decreasing its value. And so you have to link this variable. So here you can see, like, I have linked this variable to PV, which is this value, right? So go to the variable and go to the application PLC program and then select PV. So which means, like, whenever the value that you're setting here, it will be go to your ladder diagram, right? Rather than like just typing here for one time, you can just from your simulation, you can every time change this value. And in order to visualize this one, the current value, I can just add a text field, go to text field and insert this one. So it's coming as a text field. And so here I'm showing an integer. So you can see in the text field, I have to type it as a percentage value and I, which means it is showing an integer value, right? So if in the first time, if you define in this one, and then go to text and type this percentage and I, enter. So it is showing an integer value. And also you have to link this to the variable that you want to have there, right? Text variable, which is this current value of the up-down counter. For example, if I want to see this value here, the current value, I can, now it's an integer. I should go here and set my text variable as CVCTDU, right? So that is this value. So it's like a integer to string type format, like converting this integer to a string in the visualization, right? It's just like for visualization, like HMI, you know, like in the ladder logic, you can see this value, but for human, we can, from this visualization window, we can see what is the current value, and we can control this preset value from here by a human, right? So the outputs are the same. You can add to pilot lamps, and the first pilot lamp is linked to the output one, QU, the up count output, and second one is linked to the down count. So you have to type and define these variables, booleans, and then link it to the visualization. Then go and build your program and then go online. I'm assuming like you don't have any compilation errors because this one, the program I have already written, so no compilation errors. Here for QT, the down count output, you can't add a coil here. So it's just you have to define the variable. So you can't add a coil here. So it is internal disabled. So I will go debug and start. Right. So now you can see my preset value is 0 because I haven't added any value here, and the current value is also the same. And as the current value is 0 and it is equals to PV, the up counter is true, and the down counter is also true because CV value is 0, right? So now I want to load any value, like I will make this as 5. So I will just increment 1, 2, 3, 4, 5. This is like human input. So I wish to have number 5 as my preset. So this is my HMI. It's basically a virtual HMI. So I just define my preset value as 5. So when I change this one, so my ladder logic preset value is updated. And so as the preset value is, the current value is now 0. Current value is 0, which means the down count is true. The up counter still doesn't go through because the current value doesn't reach to 5, right? So I can start my up counting. So 1, 2, 3, 4, and you can see now the down counter became false because now it is no longer 0. So when I press the up again, so the current value has now reached to 5, which means the up counter is high. So you can still up counting, but only the up counter output is high, right? So you can see here that this variable is now showing in this virtual simulation environment, right? This is your HMI, so you can visualize. This is running on your PLC, but this is for human. You can see that value in here, right? So I can now further increase up this value to less up or to 10. Now you can see now the up counter goes to 0 because now it is higher than that, and the preset value has changed to 9 or set to high. So the up counter is 0 because it's the current value is 8. It is lower than 10. I can just go 1 time and 2 times. Then the up counter is now is high, right? So if I want to reset the system, I can press reset. Preset value doesn't change. The current value reset to 0, right? So if you want to make a down counter, it's better to load the preset value here. So I will just load this value, pressing load. You can see preset value is 10. The current value is 10 because these two are same. The up count is high. Now, if I want to make the down count high, so I just want to get this down count to 0, right? So I can just down counting, which means CD will be 0 all the time when I press down. So you can see now it's decrementing, and decremented value is shown in here. Right. So when it reaches 0, you can see the down counter became true. Again, you can reset, which means this one becomes 0. It's nothing going to change. So that's the demonstration of this up-down counter. If you have any questions, you can ask now before we move into practical examples. So that's all about the counters. So I have explained this example in Codesys. If you want to learn more and see few examples, you can go these YouTube links and watch how they do this examples. So it is as just for your reference. After the class, you can spend some time on watching these videos, and you can follow the videos, and you can practice to work with timers, so that will help you to learn more about timers. So I have a few examples in our tutorial section. So I hope everyone has downloaded this tutorial questions. So I'm in task 7, which is about how to use counters in a practical example. So this question is asking, using the counters, design a program and simulate in which output Q1 will be on until 3 impulses have been received from input A1, right? Which means, so you have an input which is labeled as A1 that is connected to a counter, probably up counter. So output will be on until 3 impulses have been received, which means the output is initially high. So once you receive 3 inputs from here, the output Q1 will become 0. Until normally up counter, you have always the output is 0. When you reaches to preset value, it will become high, right? Here this is inverse. So when you have 3 impulses, then the output will be simulate, which the output Q1 will be on until 3 impulses, which means the output is initially high. When 3 impulses got, the output will be 0. And then there's another output called Q2, which should be high, right? So it is very simple, which means like you should have 3 impulses, right, from input A1. So output Q1 until these 3 impulses, it is off. Sorry, it should be on, right? Q1 is on and activate output Q2. Q2 is initially off, right? So when you got this all 3 impulses, then Q1 will be goes to high, off, and activate Q2, which means Q2 will be gone to on, right? So is it clear? Which means you have to provide 3 impulses until that Q1 is on. Once you receive all 3 impulses, Q1 will be off and Q2 will be on. So why don't you try this one and Codesys? Just open your computers, try open Codesys and try to work this example by yourself. Here, so I can help you. So I have the answer, so I will discuss the answer after some time. So I'm just letting you to work by yourself. So I will ask everyone to share your screen. Therefore, just try to start it now, right? So I will call your name and ask you to share your screen. So better you try it now. Yeah, I can see people disappearing. Yeah, that's what I want to see. So one guy just left. So this is that this example. How you're going to do is you have to insert a up counter. This is A1, which is the input, which is used. I have used a momentary push button A1, and I have also used a reset button just in case I want to reset. And I can display the current value from here using a text field, the CV1 value, and my preset value is 3 because we already know that. As you know, in the question, it is asking the Q1 is on until 3 impulses, which means like initially everything is 0, CV is 0, the Q will be 0, right? So which means this one this one will be 0 initially. So I have used normally close contact of this output, which means when this is less than 3, this is 0 and this is high, which means Q1 is high, right? So when 3 impulses received, Q2 will be high, so it is Q2 here. Q2 will be high. In the same time, the normally close contact will be 0 and Q1 will be 0. So that is pretty simple. You have to build this one and go to online. Right, you can see initially Q1 is true, right? Because no impulses received. Now I can increment this one impulse. So current value is 1, 2, 3, which means Q1 will be 0 and Q2 will be high. So now I'm letting you to work this one. So I have already explained. Go to the codices and import this one and try by yourself. And I will ask everyone to share. Like I will call your name and 10 past 11 we will starting. So I'm giving you 15 minutes. So just try to implement this one. And so you should be able to show me how you did it, right? So that's a pretty simple example. And make sure you will use your time wisely, because in the assignments, if I find anyone has copied for someone else has uploaded, so you will be you will probably fail the assignments. Maybe you have to do with your next batch, right? Make sure you do try to review by your work. Don't try to cheat in the assignments or exams, right? So most probably that will making you to things get more complicated. Therefore, these classes are here to you to actively engage and work and use your time. So this is the time, and I have explained it. Try by yourself. Otherwise, you will just do nothing and then copy someone else's work and upload the assignments. Then I will catch you. Okay, now Purna is showing his program, so let's see how it's going. So can you just show this drag the visualization a little bit to the left, right side, and show the PLC program, just or minimize it slightly.
Is it okay now, sir?
Yeah.
This is the reset and Q1 is on.
Yeah, so Q1 turn off once 3 pulses got and Q2 get on, right?
Yes.
So press reset again. Yeah. Okay, that's a very good one and it's correct.
Yes.
So I will give you some time to now modify your program. Then so just make a copy of your file, right? So you have this one and just make a copy, another file, and then try this one. So in this one, in task 8, so modify your ladder diagram in task 7 using an extra timer which resets the sequence automatically after 5 seconds delay, right? Which means, so you have now used like a Purna also shown like he has used a reset button, right? In my program also I had a reset button. So you don't need to press that reset button all the time if someone wants to start the system back. So in this example, it is asking to replace the reset button, which means the whole system will be reset after 5 seconds, right? So you all need to do is add a timer and automatically reset the system after 5 seconds, which means initially starting, so Q2 will be high, Q1 will be off. So after 3 pulses, the Q1 will be high, Q2 will be off. And so by the time once 3 pulses receive and by the time Q1 get high, so you have to wait for 5 seconds. And after 5 seconds reaches, just reset the system, which means you have a reset button. The reset button is just replaced with the timer with 5 seconds, right? So now you can modify your program and so adding a timer. So I will give you some time to work on that. Then we will I will discuss that with the class, right? So take your time and work on this one. All you need to do is just add a reset as the timer. You can see here like the reset is replaced with the timer. So once Q2 is turned on with 3 impulses, so I have put a T on timer 5 seconds. So once this get high and it's waiting for 5 seconds, and after that there's a reset call. That reset call reset this count, right? So I have used to enable this elapsed time. I can see this time from text field. That is I will explain later. So you can now try that, replace this reset with the timer. Okay, now we are in the screen of Purna, so you can just demonstrate your system and show you how it works.
Now in Q1 is on, and now after 3 taps, 1, 2, 3, Q2 on, and after 5 seconds it will reset.
Yeah. Okay, good, right. So you can stop share now. It's the one where the answer is correct. Yeah. I will show you some the example here. If you want to see this time, right? So you can add a text field. Go to visualization toolbar. You can see drop a text field here, and so the text field you can define the text type as a time, right? So here you can see like I have defined it as percentage T and seconds of what is coming from the time is shown as seconds and milliseconds in milliseconds. So it will display the time. And also you have to set that variable text variable. So I have defined that this ET on 3 is my elapsed time. So I have linked that variable in the PLC program. So you have to just go and select from the application PLC T on T 3 timer and ET is my time. Then you can just link that one. So that's the variable. So then now you can see that time of the timer in your visualization. All right. So I will show you how it works. So here we go. Now you can see the elapsed time is 0. The time is 0, and I'll increment this time. Q1 is high. So 1, 2, 3. So now you can see seconds and the milliseconds in here. Whatever shown in the ladder diagram is displayed in your visualization. So that is really helpful when someone is looking at, this is the human control section, so you can, rather peering at your PLC ladder diagram, someone can, looking at outsides, he is controlling the push button and he can see these lights as well as the time, right? So just use a text field and define it as time. Even you can set it to minutes also, and that will display the time. You can link any time variable to here to display the time, like we have used for displaying the integers of the counter. Okay, now we are into the last question, which is task 9. So it is asking further modify the ladder diagram so that 1 second pulse replaces input A1. So earlier you have to press the momentary push button, right? Now it is required to replace that momentary push button with the automatic button, or you can use a 1 second pulse will update the time, right? Maybe an encoder or anything, like you can just use a timer, and the timer output can be coupled to the count. So as also it is asking use a graphical method to show the drive pulses against the output Q1. So why can't you give it a go? Try yourself, then I will explain the answer. All you need to do is just, now you have a push button. Now you can replace that push button using an internal timer in your ladder diagram. So once you run the ladder diagram, it will automatically trigger this input of the counter with the output of the timer that you're using as your input A1. Pretty simple one, you can just work by yourself. Then I will explain the answer. So this is the answer. I have used 2 cross-coupled timers. You can see one for, if you don't remember the cross-coupled timers, go to my previous lecture and see how I have explained that. So in using a cross-coupled timer, you can generate this 1 second pulse. So if you define this time, T-on time as 500 milliseconds, you can generate a 1 second pulse, which is, I have used the output of the cross-coupled timer, T-on1 out as my update my counter, this counter. And so once this Q2 is enabled, so it is linking that 5 seconds delay, and that 5 second delay is resetting this system. Here, this one I have used if I want to manually reset, I have put a manual reset push button, which I have not shown here, right? So I have used an extra start button to start the system, and Q1 and Q2 are there. Additionally, I have used this graph to demonstrate this how these time sequences are generating. And if you want to get this one, all you need to do is go here at the trace here. So it will give this trace and go to double this one, and you can see this trace window. And here task, go to the main task, and then at your variables you want to display with the time, like it's like a graph. So I want to display my T1 timer or Q1 output, whatever the variable you want to see can be inserted here. So it is over the time. So when the simulation is running, this axis shows you the time and this axis shows you the output, right? So it's like a graphical representation. Yeah. So I need to have like my start button to start the whole system. Otherwise, it will automatically start. So I have some control, like whenever I want to start the system, I can now start. So I just put in this one here. So when I'm starting, you can see this up count is updating in every 1 second period, and the output of Q1 goes as long as that. So after 5 seconds, the whole system will be reset, right? So no push button is here to activate this counter, so it is automatically updated with the second time. Or you can just I have here, you see 500 milliseconds, which means this one updating faster than 1 second. You can change this time to 1 second and see how this T1 timer works, right? So which means the T1 timer is just turned on for 500 milliseconds and turned off for another 500 milliseconds. So which means this pulsate rising edge occurs only every 1 second. So this is correct. I mean, so this the cross couple timer is like this. So this is 500 millisecond. So this is a T1 output. So every 500 milliseconds, this is high, and this is low, and this is high. So which means like this total duration is 1 second. So every 1 second, this rising edge will trigger this count like this. It doesn't work with the falling edge, so every rising edge it will work. Right. Simultaneously, you can see this output, how this Q1 and time outputs are working here. It's better to display single variable in one graph, otherwise it's this is a logic like a Boolean, or you can only see state either 1 or 0. If you add another graph to display another variable, then you can visualize them. So that's all for this example, task 9. So after the class, so you can try work on task 10, right? It is to generate like a telephone ringing tone, like in a land phone. So there are some like this kind of sequence at the speaker. So the output to the speaker or this one, so 1 second on time, 1 second off, 1 second on, and then 3 seconds off. Then it is repeating again the same sequence, right? So using timers or counters, so you have to build this one in Codesys and try by yourself. Maybe next week I will explain this, but try this by yourself after the class. So if you don't have anything after the class, now you can start working on this one before you forget everything. So that will be the end of this session. And next week we will discuss another new session of PLC program. So it's all about timers and counters are finished from here. So I have explained several questions starting from task 7, 8, and 9. I have explained you 3 examples. So task 10 is for you to work by yourself. And we will do some real world examples in upcoming lectures. So that's the end of this session. And thank you for everyone joining this class. And we'll meet in the next PLC lecture.